Hello, hello. So we welcome you back once again. The channel is PSSB, Physical Sciences Silver Bullet, and the name behind the channel is Richard. So what are we going to do today? We are looking at this question. What does it say? Okay, the statement reads that consider the equilibrium. This is an equilibrium you're looking at. And they say initially 2.4 moles of dinitrogen oxide gas is sealed in 4 cubic decimeter container and heated to 200 degrees Celsius. At equilibrium, it was found that 45% of dinitrogen oxide was present at equilibrium. Okay, calculate the equilibrium. Equilibrium constant. Okay, when you are faced with this challenge, what do? Let's use our common method. Okay, what do we have here? We are going to use the table. It's going to be the equation. Okay, what comes next? Mole ratio. What comes next? Initial number of moles. What comes next? Change in moles. What comes next? Moles at equilibrium. What comes next? Concentration. Okay, what do? That's what we are having. So we are from the formula, we have only 2 components, so we are going to divide this one into only 2 columns. So what do we have here? You have what you have in the equation. It's going to be N2O4. What do you have here? It's going to be 2NO2. From here you have the ratio 1 to 2. Okay. You have the initial, which is 2.4 number of moles. And there's something very important here. They said initially. Whenever you hear that initially, or when the reaction is just starting, there's something very important. That when the reaction is just starting, the number of moles of the product is 0. There's no product. Okay, what else do we have? We say we have something here also worth noting. The percentage present. We have to understand in this case, this is the percentage present, not the percentage decomposed. So what is the percentage present? Is 45. So if it's 45, what I'm going to say is going to be 45% of the initial number of moles. What you get will be the number of moles at equilibrium. So after computation, you have this one. These are the number of moles of dinitrogen oxide which are at equilibrium. So you put them there. It's going to be 108 number of moles. Okay, but you have to remember that when initial the reaction is starting, it goes only in one direction. So in other words, we are subtracting here, we are adding here. And initial minus this, you get what you have there. So after subtracting, what do we get? So after subtracting, this is what you get. You get a number of moles, which under this one reduced by 1.3. So what you have there, you must not forget, I will not get tired of reminding you that our mole ratio controls the change. Okay. So what do we do when we have this number of moles here? You got the ratio. This one is 2. So it's going to be 2 times this 1.32. And what you get is going to be that. So when you multiply that one, what do you get? So you get 2.64. Thank you. So from here, you have to remember something, that the number of moles of the product are increasing. So that's why you are adding. So 0 plus this, you get a number of moles at equilibrium, which is going to be 2.64. Okay. So what do you get? How do you get the concentration? You used our formula C is equal to N over V. So if our N is 108, what is the volume? The volume is 4. And what you get will be the concentration. The same applies to this side. It's going to be 2.64 divided by 4. What you get is going to be the number of the concentration at that point. Let's get them and we see. So after getting the concentration, what do? We go to our expression. And what does it say? It says Kc is equal to concentration of the product raised to its power over concentration of the reactant. Okay, what do we get here? It's going to be 0.66 squared over 0.27. What you get from there will be your Kc. Let's do it and find out. So after substitution, this is what you get as our Kc, 1.61. Okay. So like we always say, thank you. We appreciate your time. Don't hesitate to contact us in case of anything. And see you next time. The channel is PSSB, Physical Sciences Silver Bullet. And it's Richard behind the channel. See you next time. Bye.